Greetings to all in Dr. Abha Chemistry Pathshala. Let us quickly talk about reduction of. As you know, benzene always undergo electrophilic substitution. So, whenever we have any function group attached to benzene, something like aldehyde or ketone or acid, it will undergo electrophilic substitutions. Although always the OP directings will undergo electrophilic substitution faster than the meta directing. So, let us talk about electrophilic substitutions of benzaldehyde and of aromatic ketones. Over to the screen for better reaction of aromatic aldehyde and ketone. So, here we are going to talk about the reaction that takes place in the benzene ring, right? So, there are reactions that take place in the carbonyl part, but here we are going to talk about the reaction that will take place in this part, right? These reactions are slower than the reaction which are shown by benzene ring. The carbonyl group on the benzene ring is meta directing, hence the electrophile will get substituted at the meta position, unlike in phenol, aniline and chlorobenzene where it gets substituted at the ortho and the para position. So guys, if you remember, I'll just draw one of the structure and you would remember the entire thing. So if you want, you can go through the electrophilic substitution of benzene ring. So here the electrons will be driven out of the ring and we will have a positive sign here, that is, so electrons are being driven out of the benzene ring and we are getting a positive electron density which will repel the electrophile at ortho and para. So at the result we will only be left with meta position where the substitution takes place. So let us look at some of the electrophilic substitutions. So look at the first one. I have taken acetophenone, that is, you also call it phenyl ethanone, and I have shown the chlorination of this, and the chlorination is taking place at meta position. I have not written the chlorination of aldehyde. Why? Because this gets during chlorination this gets oxidized to carboxylic acid, hence we do not have chlorination for benzaldehyde. If we look at the second reaction, this is for the formation of meta nitro benzaldehyde. This is a usual nitration, but I have written 50%. This 50% is because rest 50% of the product will give benzoic acid because of the oxidizing nature of the nitric acid. This benzaldehyde will give benzoic acid. So we only get 50%, but if we perform the same reaction for ketones, that is aromatic ketones, we will get meta derivative 100%. Okay, so next is sulfonation. Sulfonation reaction is exactly the same in both, like in benzaldehyde also the sulfonation takes place at meta position, and in acetophenone also it takes place at meta position. Let's see, the Friedel-Crafts reaction is not possible in benzaldehyde, also it is not possible in benzophenone or acetophenone, also it doesn't take place. The reason being that the aluminium chloride, which is a Lewis acid, it gets bonded with the lone pair of electron and the reaction is restrained. So that's why we take, when we do the halogenation, we take excess of aluminium chloride, right? But in Friedel-Crafts, if the reaction is not possible because of the complex formation. So these are the substitution electrophilic in benzaldehyde and aromatic ketones. So we meet in the next class with the new topic of aldehydes and ketones. Till then, take care of yourselves.